Okay, so what we're doing in this chapter is we are talking about comparing two proportions. We're going to break this video down into two parts. Part one is going to kind of introduce it into a confidence interval. And part two, we will do some hypothesis testing to see that process. So what's nice is you kind of already learned everything you need to know. We're just adding one extra step right here. And the difference is we're doing the difference between two groups. Usually we just had one proportion and it was either an increase, decrease, or a change. And what's happening now is you have two proportions. So I have proportion 1 and proportion 2. But one is either greater, it's less than, or it's not equal to. So again, greater than, less than, or a change. Okay? So the only thing that I do want us to make sure that we kind of understand is that with proportions, remember our hoes always stay the same. And so when they stay the same, that means there's no change. And so the way we'll actually write it is we will not say equal, they equal each other. Instead, we're going to do P1 minus P2 is equal to 0 because there's no change. There's no difference between the two. One thing that you might want to do, or we want to do, is we want to make sure that the bigger percent goes first and then the smaller one goes second. And the reason we want to do that is because then we don't get negative numbers all the time. You will still get some negative numbers, but not as many, because negative numbers can sometimes be difficult to interpret. So make the problem easier for you, and whichever percent is bigger, make that be your first one. Okay? So for our hoe, again, it's P1 minus P2 is equal to 0. And then our ha, it'll be greater than 0, less than 0, or not equal to 0. Okay? And again, we'll do some practice of writing our hypothesis and doing the whole hypothesis test process on part 2 of this chapter. All right, so the next thing we have is we need our standard error for this chapter, our standard deviation. And so we already have the formula, but that's when we only had one proportion, right? But now we have a second one, so we just add it on. Keep the same formula, but add on the second set. Okay. What is nice about this chapter is you guys already know your conditions. You know that they have to be random. You know that it has to be less than 10% of population. You know it has to be independent and your success failures. The only difference is you have to run it for both sets. And then this independent groups means groups are independent from each other, which kind of makes sense. Okay. And so for success failure, make sure that you do NP and NQ is greater than 10 for the ones. And then you also have to do it for the twos. Oops, that's supposed to be a P. Okay. And then when we do an interval, the confidence interval, the name of it is going to be a difference of proportions Z interval. So difference of proportions Z interval. You could abbreviate it a little bit by doing, you could say diff prop to Z int, but you got to know that there's two proportions there. Okay, so what's nice is you guys already know how to find a confidence interval. Your confidence interval is your mean plus or minus your critical Z times your square root formula, the one that's all the way up there. So right there, that thing right there. Bring that down. Let me show you so you can see. Come here. There we go. So it's just the square root of P1 Q1 over N1 plus P2 Q2 over N2. I'm not going to write it again. So the question is, though, how do I find the mean? Okay, well, we're subtracting our numbers. And so it's going to be, to find the mean, it's going to be P of the big one minus the P of the small one. because we're always doing big minus small. Okay. All right, so let's go do an example. Let's look at example 1. We'll fill in the other information later. Right now, we just want to do this example. Okay, so the presidential candidate fears he has a problem with women voters. His campaign staff decides to run a poll. They randomly select a sample of 300 men, 300 women, and ask if they have a favorable impression of the candidate. There's a positive image with 59% of men and 53% of women. To determine a 95% confidence interval for the difference between men and women. Okay. It tells you difference right here with men coming first, but also if you look here, men is a larger percent, so I'm going to do men first. I'm going to say men are my P1 and P2, or my P1 and Q1. Okay, so let's name it first. So we're doing a difference of prop Z interval. Ooh, that's kind of ugly. And then we need to label them. So my N, you could do it two ways. You can say men here and then label and then label them this way, right? But I don't like doing that. I think that's just a little bit more work. What I do instead, where's my eraser? What I'm going to do instead is I'm just going to say the N of men. And I know M stands for men. So P of men. Oops. And then Q of men. So if you don't want to have to say what 1 and 2 are, just put a letter that represents what each one is. As long as I'll be able to know what it is, then you're good. And then there's women, which is 0.53 and 0.47. Okay. So we have our name, we have our parameters. Now we need to check our conditions. I would like you guys to try and check your conditions on your own. And when you think you have it, go ahead and press play, or the sub will press play in a few minutes for you to check what you got. Okay, here we go. So both samples are random, which it says. And then 300 men and 300 women are less than 10% of men and women. Opinions and groups are independent. And then I showed that both sets had at least 10 successes and 10 failures. Okay, so now we're going to do our interval. And so remember our interval, I'm going to use a fancy pen, is going to be our mean plus or minus our critical Z times P1, Q1 over N1, and then P2, Q2 over N2. And so remember our mean is just when we subtract, and we're going to do men first because men's bigger. And so 59 minus 53 is 0.06. And then our critical Z, 95%. Remember our critical Z for 95% is 1.96. And then we're going to type in all this. So 0.59, 0.41 over 300, 0.53, 0.47 over 300. And what you should get is 1.96 times 0.04. And so now our critical, our condition, or gosh, I forgot the word, our confidence interval, when I subtract it, I think was a negative. Yep, it's negative 0.018. And then when I added it, I got 0.138. Okay. So we haven't had a lot of intervals or anything that's a negative percent because negative percents usually don't exist. But for this problem, remember we were subtracting men minus women. That's what we did. We did men minus women. So when we have a negative percent here, because it's negative, that means that women was a higher percent. But then when they were positive, that means men was a higher percent. So it wasn't that often that women were a higher percent, but there was some time. Okay. All right, so now to interpret it. We still interpret it the same, but it definitely is trickier to interpret these because we're doing a subtraction problem. We're doing the difference. I'm going to see if I could type it versus... Let's see, hold on. Okay, so we're going to start off the same. We are 95% confident. But we are talking about the difference and when one group's higher than the other group. And so I'm going to talk about this because I did men. I'm going to do men first. We are 95% confident that men have a favorable opinion of the candidate between 13.8% more and 1.8% less than women. Because sometimes the men were higher and sometimes they were lower. If we did it the other way, where we think about women, then it would be we are 95% confident that women have a favorable opinion of the candidate between 1.8% more and 13.8% less than men. So it depends on how you look at it, which one you say. You just have to know that when it goes to a negative, that means that one group, it switches, then it's not always men are always higher. Sometimes women are higher. Okay? So with confidence intervals, you've done a lot of this before. The biggest difference now is that when you find the mean, you do that by subtracting the two proportions. Make sure to check your conditions, list all your parameters, and then you just use your formula and interpret.